Okay, good day, everybody. So today we're going to finalize our review for the test. The test is tomorrow and on Friday, so 2-day test. Your job tonight is to finish up your review packet, kind of get it all squared away. If you have any questions over anything up until the last little sections, that'd be a good thing to ask today as well. And today shouldn't take very long because the things we're reviewing are the most recent stuff, and they were pretty straightforward. They were solving inequalities and systems of equations and things like that, which were pretty straightforward skills based on things that we had already known from before. Okay, so number one today, we have this inequality. It's got a mixes of x's and y's. So if there's x's and y's, that's a key to you that there's going to be some shading involved. Okay, you're going to be shading above or below or things like that. So in this particular case, you want to graph it first. Now, this is not set to graph right away because you usually got y by itself, right? Y equals something, so get y by itself. I'm going to move the 1 over. And in that case, you have x squared minus 1 is less than y. So you try to get y by itself, like always. If you have trouble reading it backwards, you know, what's this saying? Y is more than it, right? It's the bigger one, right? So if you want to rewrite it in the traditional order where just, you know, y is on the left, that's okay. It's not really necessary. But sometimes I find students find this easier to read and interpret than that right there. Okay, so you got to graph this thing. Now, when you graph it, x squared minus 1, there's lots of things you can do. You could go find the vertex, you could go find the axis of symmetry, or for a simple problem like this, x squared goes through the origin, correct? And the minus 1 just shifts it down 1. So you should know it's a quadratic going down here, hitting down here at -1. So that's the fastest way to do it. Should you draw this thing solid or dashed? This is solid and dashed kind of stuff. This should be dashed, right? Because it doesn't actually include it. So you draw a nice little quadratic going down. It should cross down here at -1. It got shifted down 1, something like that. That's something to know. So yes, you would still want to probably identify where the vertex is and be sure where that is. It's down here at 0, -1. And then all you got to do is shade either above or below. Now, this one's saying y is more than it, so we're looking for things above this graph, so I'm shading above it. So anywhere where the graph is, just shade above. There you go. Anything above that little dashed line is going to count, and that's all there is to a problem like that. So nothing too tricky if there's x's and y's. Just get the y by itself, graph the thing with solid or dashed lines appropriately, and then shade appropriately above or below. So that's that entire concept there. Number 2. This has no y's, so it's still an inequality. So if there's no y's, that should be a hint that you're looking for when the graph is above or below the axis. You're going to write an interval. So from here to there, it's above, or from here to there, it's below, or something like that. But this thing, there's no y's, but you want to compare it to the magic number of 0. That is your strategy on this stuff, 0, 0, 0. So the first thing you need to do is get everything to one side, so that is compared to 0. It really doesn't matter which side you pick. I think probably easier to move this stuff over here, honestly, because if I take away this x squared, that'd be a positive x squared thing over here too. So let's take all these things on the left and move them to the right. To do so, we would have to subtract x squared from both sides, correct? You had a 2x squared, correct? So if you take away an x squared, that would just leave you with an x squared. As far as x's goes, you had this 3x. You want to get rid of it. You need to subtract 3x from both sides. So 5x minus 3x would be 2x. And lastly, you want to move this 6 over by adding 6, and -5 plus 6 is 1. So this is really a simplified, nice little cute thing to take a look at. All right, how do you do this? I would recommend well, you need to know when this thing is more than 0, above the axis, right? So it'd be really good to know where it crosses the axis. That's the first thing you want to know. And where something crosses the axis is known as a 0. So we need to figure out when this thing actually equals 0. How do you figure out when a quadratic equals 0? Lots of ways to do it. You could do anything from yesterday. You could factor, or you could do quadratic formula. Does this factor? It does. I gave you something nice. This factors into x plus 1 and x plus 1. So off to the side, I'm just asking myself, okay, when is this thing equal 0? And it's clearly only at one number, -1. Would you concur? So over here at -1, there is a 0. It's going to cross the axis at that one point and that one point only. Will the quadratic be opening up or down? Well, it's a positive x squared thing, right? So it's going to open up. Yep. So something like this is what you would do if you graph this thing. And graphing is another option you could do. You could go graph this thing, and it would look exactly like that. Now, the point of all this wasn't to figure out exactly where it's 0, but to figure out where it's more than 0, correct? So tell me where it's above the axis. That's all we're doing. How about over here? Is it above the axis over here? Yeah. How about everywhere until -1? Now, -1 is above 0? No, it's equal to 0. Does that make sense? Right there, it's equal to 0. I don't want to equal 0. I just want to be greater than 0. So I don't want to include -1 itself. But anything after -1, how about -1 to infinity? Is it also greater than 0 there? Yeah. So the final answer to this is all the numbers everywhere except for -1. Anywhere where this graph is above the axis here, and that's everywhere except for at that one lone number of -1. So all the real numbers skipping over -1 would be my answer for that. So that's essentially what you're going to be doing on these inequalities. Okay, if the first one is x's and y's, that's a shading thing. If it's just x's, compare it to 0 and see if it's above or below according to the thing, and write out the interval where that occurs. So that is all there is to solving these kind of inequality stuff. Only other thing to worry about was systems of equations. So if they give you a system of equations like number 3, you do exactly what you did back in the day with linear systems of equations. Just because it's got squares in it doesn't mean the rules are any different. You'll have a couple equations. You'll want to either use substitution or elimination to solve them. I would strongly suggest substitution. That always works. And if you look at this one's already solved for y, correct? So why don't we just substitute it into the second equation for y, and we'll see what it turns into. So the second equation now reads x plus, and it used to be y, but y is x squared minus 6. So I write x squared minus 6 instead. And then it turns into this thing right here. X plus x squared minus 6 equals 6. And now we're down to one equation with one variable, x's. It's a quadratic. Squared things, you should always think of saying equal to 0. Seems like that's the same thing we do all the time, set things equal to 0. So why don't we move this 6 over? And while we're at it, let's write this in a better order. X squareds come first usually. There's an x. And when you move the 6 over and subtract it, you already had a -6, and subtracting 6 more would make it -12. So we get down to this little quadratic thing here. Of course, we can always use quadratic formula on anything if we want to, but this does factor. Do you see that it factors? That is right. X plus 4 and x minus 3. So much faster to factor if you can see it. And that means the two answers are for this one, either x is -4, or for this one, x is 3, whatever makes those factors themselves equal to 0. Once you got one of them, you go back and plug it in somewhere. And you remember the system of equations, x's and y's, you do want an x and a y for each option. So you got to go back in each case and figure out what y is. We'll do the -4 first. If I take -4, this first equation is not so bad. -4 squared is 16, right? 16 minus 6 is 10. So in this case, one solution would be -4, 10. For the other x that we got out of 3, if you plug that back in somewhere, same one probably, 3 squared is 9. 9 minus 6 is still 3. So here are my two solutions, -4, 10 and 3, 3. And that means that these two graphs will cross that spot. Again, this does mean something graphically. This is kind of a graph of x squared minus 6. And a graph of this one would look something like this, and they would in fact cross at two numbers. Guess where they are? -4 on the x and 3 on the x for the other one right over there. For any system, you should probably write the buzzwords down. This is consistent. Write the word consistent. Yes, we got some answers out. Nothing funky happened in our work, so it is also independent, consistent and independent. And those are the kind of things you need to check off on your review assignment as well. All right, that's pretty much all we're going to talk about today. It shouldn't take very long. LGs real fast. Finish reviewing for the test. Those are really the only concepts we need to talk about. They shouldn't take very long. System of inequalities. Just make sure you shade appropriately for x's and y's. Review packet due tomorrow, of course, so have that turned in by the end of the day at the very latest. Preferably have it done before the test, because that's the point of it. So try to get that done. Test tomorrow. Here we go. Okay, a lot of people have been asking for extra credit. So here's an opportunity for you if you want some. Now, I don't believe in buying your grade, so I will also put something online which is a very long packet about fractions. Most kids don't choose to do the academic route. Most people choose to buy some things. So here's some classroom supplies that if you would like to buy, I will put these points towards your tests. That's a big deal. I usually don't do that. I put points towards homework assignments. But if you would like to earn a few extra credit points, here's a few ways. You can always use more extra expo markers. So all these things are for the classroom, maybe myself or something else. But expo markers, if you give me darker black ones, I'll give you 3 points for each pack of those you get me. You can go up to 20 points max. That's like 10% more on a couple tests. That might help a lot. So I strongly encourage you to take advantage of this or do the online work if you actually want to earn your grade. Batteries are always good. I could always use AA or AAA for my calculators around here. So 4 points each for those. I like my coffee. So if you want to buy me some black silk coffee, that'd be fine. And I always use my coffee creamer. So if you want extra credit, here's a chance to buy some. And I will also be giving you guys a packet online, which I'll post later today. And if you do that, I will grade it straight up. And whatever percentage you get on the fraction packet, that's what you get out of 20 towards your test grades as well. So that would be a very valuable thing to do. Any questions over that? All right, so there's a way to get some extra credit. All right, continue with our review today. We are finishing up the last few sections. We are on section 3.7 to start off with quadratic inequalities. And what this one is just saying is if you're graphing a quadratic inequality with y's and x's, these are the ones where you're doing shading above or below. So really don't have much to say about that. I guess the one thing that you should point out is if you get y by itself, let's say you had this thingy right here, you should know that if it's greater than or equal to means it's actually the line. So you actually fill the line in. It'd be a nice solid line here, correct? And if it was not equal to, then we do a dash line because it means I can go right up to it, but not actually include that line right there. And this one you would shade what, above or below? Above. You're looking for y's more than it, right? Y's more, y's are getting bigger, up above. And then vice versa. If they had something like this, you would go shade, it'd be a solid line, correct? Because y can equal that graph, but you'd be shading this one below it. That's kind of all there is to that. If there are just x's or something like that. So say I gave you this problem right here. What you would go do is you would probably go graph the stupid thing. And you would look at it visually, where is this graph itself above 0? And 0 is just the axis, fancy word for the axis, right? So you're reading off with just x's where on the x-axis it's above 0. For this particular problem, it's always above 0, isn't it? So my answer for this one would be negative infinity to infinity. If I gave you another graph, though, and it looks something like this, and this was -2 and this was 3, oh, I don't know what this function is, but let's say I asked you when it was more than 0. What would your answer be if this was more than 0? Well, it'd be everything over here, correct? And everything over there. Your answer would be negative infinity until -2, right? Union 3 to infinity. Make sense on that? And then if I said less than or equal to, let's say, well, where's it equal to 0? At -2 and 3, correct? And everywhere in between it's less than, right? So for this particular problem, your answer would be bracket -2 to 3, and you include them because you're including 0. That's kind of all there is to that stuff. Let's do an example problem. Anything 26 through 30 would be something like this. Anyone look particularly challenging or gross or anything you want to do? 27. All right, let's do that. That does look kind of weird. All right, 27. And you notice by 27, there's a big graph, right? That's a big key to you that you should be doing some shading, right? Because I need to see some shading as your answer. And it's got y's and x's. So here we go. Y is greater than -x squared minus 6x minus 7. All right. On these kind of problems, I need to draw it accurately. That's kind of the key thing right here. So let's see. I need to shade what? Above it, right? And this quadratic will open down, right? So if I'm going to be really anal about this, how would I draw the quadratic very accurately? I might want to go back to that good thing, x equals -b over 2a. That tells you where the vertex is, correct? That's a gold mine right there because it can tell you exactly where things are going to start. So let's do that one. -b would be +6, correct? Over 2a, a was -1, so that's -2, and we get out -3 when we do all that. So at least I know that this graph is going to be over here at x equals -3. There'll be this axis of symmetry. You don't have to draw the axis of symmetry. It's not required for this problem, but why the heck not? So there's your axis of symmetry. Where's your vertex going to be? Well, how do you find out? Just like way back in the beginning of the packet, you take the number and you plug it in, right? So if you plug it in carefully, -3 squared is 9, but there's a negative in front, right? So it's -9. -6 times -3 is +18, correct? And this is -7. You do all that stuff and you get out 2. So your vertex will be right there. And there's nothing wrong with graphing this too. You could just go graph this thing in your calculator and it would show you something with a vertex right here. And that would open kind of down. But I shouldn't draw it solid, should I? I should draw it a little dash thing. So that's probably good enough. It doesn't have to be a perfect sketch, but please, it's got to open the right way. Don't draw it over here opening up. Clearly that's not correct. So you don't have to be too anal about it, but get the vertex about where it should be. Opens down. And then all you're supposed to do is, this is shading one, right? Y is greater than, shading than. So you need to shade above it. So shade everywhere above your little dashed line, and you're done. That's essentially the problem. Nothing too bad on that one. Cool? Questions over anything? All right. And then the very last section that we had to review was very simple, and it's just like we talked about, the systems of equations. So if you have a system of equations, like usual, you can use elimination, you can use substitution. Try to avoid solving them by graphing because it's a very unreliable thing, especially when you get out weird answers with square roots and stuff like that. So you want to avoid graphing. But again, just solve for one thing and plug it in the other one, and then you're done. I really don't have much to say about that. So I think we should just practice one again. Let's practice one problem, and then we'll be all done. Anything on the back page? Anything on the back page? 34. All right, here we go with 34. Does look kind of gross. All right, number 34. Two equations. Both of them already have y solved for. So equation 1 has y equals x squared minus 3x minus 10. And equation 2 is y is 2x squared minus 50. They look a little intimidating, but you already solved for y, right? So just plug it in for y in the other one. So the first equation, if I know what y is, if y is x squared minus 3x minus 10 in the first equation, then that's what y is in the second equation. So substitute that in equation 2. Now it reads x squared minus 3x minus 10 is equal to 2x squared minus 50. So I just did straight up substitution. Always works. Substitution is probably the best method. Elimination is cute, but it doesn't always work. All right, and we got this thing. How do we solve this? Well, it's a quadratic, so set equal to 0. It doesn't really matter which side is 0. I'm actually going to, for once, I'm going to move this stuff over here. You know why I'm going to move 3 things over instead of 2? Anybody know why? So I have a positive x squared. Yeah, you don't have to do that, but I'm going to do it. So I'm going to subtract the x squared from both sides. So now it's taken away. The 2x squared is equal to x squared over on the right. To get rid of the negative 3x, I'd have to add it over. So it'd be a positive 3x over on the right. And to get rid of the minus 10, I'd have to add 10 to both sides. And negative 50 plus 10 is negative 40. So here's what I'll end up with, a nice, clean, compact quadratic. I should always try to factor first. If that fails, I go to quadratic formula. Does this factor? 40. What goes into 40? 20 and 2. 20 and 2 in any way go together to be 3. Not really. Let's try something different. Anything else with 40? 5 and 8. Oh, that's promising. 5 and 8 somehow make 3, right? So how about x plus 8 and x minus 5? Does that fit? Oh, it does. That's so much faster than doing the quadratic formula. Because now apparently the answers, one of them says x is negative 8, and the other one says x is 5. So I've solved for the x's. Isn't that nice? Of course, you're not done until you solve for both x and y. It's a system of equations. I got to solve for both x and y. So you have to go back and do them separately and plug them in and see what you're going to get for y when you do. Getting a little lazy with the mental math. The heck with it. I'll do it. Negative 8. Plug in this one. Negative 8 squared 64, correct? So that'd be 64. Negative 8 times negative 3 is positive 24, correct? And when you do all that math, that turns out to be 88 minus 10, which is 78. That's a big number, but that's what it is. So y equals 78. And if you were going to try to solve this by graphing, that means you have to make your window pretty darn big. You wouldn't see them cross to way up there outside your screen. So another reason to avoid graphing, because it might not be in the normal window. This one right here, when x is 5, well, let's plug 5 in and see what we get. 5 squared is 25. 3 times 5 is 15. So when you do all this math, 25 minus 15 is 10. And 10 minus 10 is, well, that's nice, 0. So there we go with that. Your answer should look something like that. There's a spot that says solution or solutions. Write them separately like that. You can write them as a coordinate too if you want. These are points where they cross, but I'd avoid that. I would just write like this. Write this one out. Write that one out. And of course, they got the buzzwords up top there for a system of equations. Consistent or inconsistent. Which one should you circle? Consistent. Yes, you got an answer. And there's a spot for independent and dependent. This was independent. Nothing funky happened. There was no 0 equals 0s or 5 equals 5s or anything like that. So we're all done with that. So just substitute something in, and then you're just going to have a quadratic to solve, which means you got 2 answers. Well, that's okay. If you get 2 answers out, go back and plug them in separately. You'll get 2 different y's out and 2 different coordinates where they cross. Good on everything, guys? All right. So that's all there is for the review. Your test is tomorrow. So your job tonight is, of course, to get the rest of the review packet taken care of. If you have any questions, you have any questions over anything in the packet up to this point? Anything? It's okay if you do. Nothing? All right. I expect a lot of A's then. Don't break my heart.